Mr. Speaker, Your Excellencies, esteemed fellows, ladies and gentlemen. In the last 10,000 years, our civilization has made an incredible journey. From a few million hunters and gatherers to today's high-tech civilizations and megacities with nanotechnology, supercomputers, and personalized medicine. It's a staggering development that would not have been possible without all the knowledge seekers, and we have many of them here, scientists, innovators, engineers, driven by the desire to investigate, to understand, and find new solutions. A force that time after time has contributed to giant technological leaps that have really driven our civilization forward. But new technology has not always only been received with open arms, it has also created anxiety and raised questions. Concerns were voiced in the 40s when physicists learned to control nuclear reactions, or when geneticists in the 70s showed that it was possible to edit our genes and tailor the code of life. And today we are debating potential risks and threats of artificial intelligence, which is taking giant steps to our everyday lives. And this is an important discussion. In the face of any new paradigm-changing technology, it is wise to weigh the benefits against potential risks. But if there's anything that history has taught us, it is that discoveries cannot be cancelled. What has become known can not become unknown ever again. So new knowledge breeds new technology, and introduction of new technology in our lives can indeed become a balancing act between incredible opportunities and unforeseeable challenges and risks. But in the dawn of new technology, we don't know which one is hiding the next giant leap forward. So perhaps such a leap will turn out to lie behind one of those important technological advances made in Sweden in the past year.
It's one small step for man, one giant leap for mankind.
Artificial intelligence has undeniably been the technology area where giant steps forward have been taken in 2023. For years, AI companies have been developing language models, AI-powered software that can learn languages by reading and analyzing huge amounts of text. But in the past year, the development exploded with the release of ChatGPT.
Things have moved fast since OpenAI in November last year released a free version of ChatGPT, the chatbot that already by January this year had become the fastest growing consumer software application in history. Using its regenerative self-learning language model, ChatGPT is able to use natural language, deliver answers to complex questions, compose music, summarize large amounts of information, and help students write essays. During the past year, a full-scale race has been underway, as the former non-profit research lab OpenAI has been competing with giants like Google, Microsoft, and Alibaba to deliver new and increasingly advanced chatbots and language models. A development that Sweden as well has been part of since AI Sweden, the National Center for Applied AI, released GPT SW3, the first large-scale language model in Swedish. And while many corporations, industries, and people in general quickly have begun to see the huge potential of the new technology, others have raised concerns over the ever faster AI development.
Apparently, an eventful year for artificial intelligence. The possibilities of AI may very well be a game changer for humanity. But on our way there, it is crucial that we find frameworks and regulations to make sure that we can handle the choices and challenges that may arise. Another field of technology where great progress has been made in 2023 is quantum computing. Quantum computers are based on so-called qubits that can hold much more information and enable much more complex calculations than today's supercomputers. The problem is that the current early prototypes of quantum computers are sensitive to disturbances and noise, which can cause them to calculate incorrectly. But today, science teams in several countries have come up with possible solutions to make quantum computers more reliable. In California, researchers within the Google Quantum AI project have found a way to reduce the number of calculation and errors by grouping the qubits in a different way. This is an important step towards building large-scale quantum computers, as the number of errors decreases the bigger the computer gets, instead of the other way around. At Chalmers, another possible way to compensate for calculation errors has been developed by Dr. Martin Rahm and his team. The method, reference state error mitigation, or REM, involves first using a quantum computer and a conventional computer to calculate a simpler version of a more complex problem. And the differences in these results can then be used as a template to correct errors made by the quantum computer as it tries to solve a much more complex problem. The new method has already enabled this research team, among the first in the world, to use a quantum computer to simulate a chemical process. And this is an important step forward that could have major impact to the development on everything from medicine to new materials. The study is made in collaboration with the Wallenberg Center for Quantum Technology, which is led by Professor Per Delsing. In the ongoing transition to a fossil-free economy, batteries are one of several technologies that can be used for storing energy. Batteries have great future potential, not in the least when it comes to electrifying the transportation sector. This potential is indicated by calculations by Dr. Anders Grauers and Johannes Karlsson at Chalmers that suggest that already today, driving heavy trucks on batteries can be cheaper than driving trucks on diesel, if driven economically. However, if batteries are to make a major breakthrough, they need to become cheaper, lighter, more efficient, and greener. And here too, progress has been made. Electrolytes are liquids that conduct ions between the two electrodes of a battery, which is essential to its efficiency and lifespan. Today, many batteries use organic solvents that are flammable, and they are often harmful for the environment and health. Dr. Faiz Ullah Shah and colleagues at Luleå University of Technology have now developed a technology based on highly conductive liquid salts, aromatic, heterocyclic, anion-based ionic liquids. They can be used as electrolytes in next-generation batteries, which are more efficient and greener than current batteries. Professor Alexander Matic and his team at Chalmers have collaborated with Swiss and Danish scientists to develop new technology based on X-ray tomography. The new approach allows detailed studies of the process inside the batteries when they are used. And in this way, they can identify problems and test solutions that will help develop new types of batteries that are both lighter, they are safer, and more energy efficient. Hydrogen gas is another very promising solution for energy storage, even in industrial scale. And the progress in this area is very fast, with many recent advances in the production of hydrogen gas. Photoelectrochemical water splitting to hydrogen gas and oxygen can be used to convert energy from solar power into storable fuel. The current processes typically rely on lead-containing photoelectrodes, or LDPs. But the poor stability of LDPs in water, together with the toxicity of lead, restrict their practical application. So Dr. Manning Liu at Lund University and his co-workers at Tampere University have now reported the first ever synthesis of water-resistant nanocrystals with high structural stability. This is a new, promising concept for the fabrication of eco-friendly, low-cost and high-performance photoelectrochemical water-splitting cells for converting solar energy into fossil-free hydrogen. Another risk for large-scale applications of hydrogen gas is that in contact with air, it becomes explosive. And the team of Professor Christoph Langhammer at Chalmers, together with Dutch scientists, have, with the help of AI, built an optical sensor that can reduce the risk of accidents. The surface of the sensor consists of metal nanoparticles that can detect changes in hydrogen concentrations in the air at a sensitivity of only a few hundred thousandths of a percent. So the new sensor can detect hydrogen gas and set off an alarm if a leak occurs. Safety has also been the focus of several other examples of technical advances during the past year.
Safety is a key issue when it comes to developing autonomous vehicles. Today, most self-driving vehicles navigate by using optical sensors like cameras and lasers, technology that can run into problems when driving in conditions with bad visibility like fog, rain or heavy snowfall. To solve this problem, a research team at Örebro University has turned their attention to shipping, where a different technology have been used to navigate bad weather for almost 100 years: radar. Unfortunately, radars have not been accurate enough to be used in self-driving vehicles. But now, the engineers at Örebro University have developed a method based on a spinning radar that is able to pinpoint the position of a vehicle with an error margin of only 1%. A radical improvement, now making radar a possible solution to help self-driving vehicles navigate safely, even in the most challenging environments. Crash tests is another technical aspect of road safety. For decades, the dummies used in crash tests have been made to represent the average man, even though women in many types of accidents are at greater risk of injury than men. Now, engineers at VTI, the Swedish Road and Transport Research Institute, have developed the world's first female crash test dummy, Seat Evaluation Tool 50F. The project has been led by Astrid Linder, Professor of Traffic Safety, in collaboration with colleagues at VTI and Chalmers.
We have used the wood for thousands of years to improve our lives, constantly trying to find new ways of using and manipulating it to serve new purposes, such as environmentally friendly materials. Today, we are experiencing a dire need of solutions for developing sustainable energy systems. And a promising option is to exploit environmental energy through spontaneous water evaporation, a process in which wood can play a role due to its physical properties and ability to attract water. However, current wood-based water evaporation-assisted power generators are suffering from very low power density. But now, KTH scientists Johan Lee and Thomas Larsson at the Wallenberg Wood Science Center have used nanotechnology to improve the properties of wood. And by doing that, they have been able to enhance the natural process where small amount of so-called bioelectricity is produced when water evaporates from wood. Already at this very early stage of the development, the nano-enhanced wood can power LED lights and calculators. But this work paves the way for sustainable energy systems, which can be rely on nano-engineered biomaterials. The constantly growing need for sustainable energy is one of the biggest challenges of our time. Within a few decades, more than 30% of the world's energy consumption is predicted to go to processing, storing, and sharing digital data. Here too, development of new materials offers keys to progress. Scientists at Uppsala University, Chalmers, and the Max IV laboratory at Lund have succeeded in producing a very thin magnetic quantum material. This opens possibilities to develop much smaller, faster, and more energy-efficient memory components in computers. Similar materials have been produced before, but the Swedish scientists led by Professor Saroy Prasad Dash at Chalmers are among the first to make it work in room temperature, which is a key to practical applications. Important steps forward have also been taken in the development of new materials for biomedical applications. Discoveries based on Professor Cecilia Persson's research at Uppsala University have made it possible to produce what they call soft bone cement. The material can be used, for example, to repair spinal fractures, especially for patients suffering from osteoporosis. Commercialization of the materials is now on its way in the spin-off company Inossia, which in March received over 7 million euros from the European Innovation Council. The commercial potential of the material is enormous. Over 40 million people only in Europe and US suffer from osteoporosis, which every year leads to almost 9 million broken bones. Other advances in medical technology are paving the way for new innovations that may prove to be of great importance for global health. 20 years ago, the work on building the Human Protein Atlas was initiated, an open access database with the goal of genetically mapping every protein found in the human body. Matthias Ullén, professor at KTH, serial entrepreneur, and the founder of Science for Life Lab, has led the project from the beginning. And in January this year, the 22nd chapter of the Atlas was released, a genetic map of over 1,400 blood proteins that in previous research have been linked to cancer. The map can now be used to develop methods for early detection of different forms of cancer based on a single drop of blood. CTI scanning is an important tool for timely detection of severe diseases like breast cancer or heart disease. Professor Mats Danielsson and his research team at KTH have worked over several years to develop a completely new type of CT scanner. It creates X-ray images by counting photons using a silicon-based detector. And in this way, they can provide three-dimensional images of the body in more detail and with lower radiation doses than conventional CT scanners. The true potential of the new scanner in healthcare has now been also verified in a clinical study on patients at Karolinska University Hospital. Another breakthrough in utilizing CT scanning has also been achieved at KTH to make open heart surgery safer and more successful. When planning for such an operation, surgeons need as much information as possible about the patient's heart. In collaboration with colleagues at the Cleveland Clinic, Dr. Elias Sundström at KTH has developed a new visualization technique. It is using input from CT scanning to create three-dimensional images of the patient's beating heart already before the operation begins. In the future, the new method could be used to reduce the risk of complications for the hundreds of thousands of patients who undergo this kind of surgery every year. Just like last year, in 2023, several important technological advances have also been made in space.
In January, Spaceport Esrange, Europe's first launch site for satellites, was inaugurated outside Kiruna in Sweden. The site is an expansion of the Rocket Range and Space Research Station opened up in the 1960s. Until now, to launch satellites, the European Space Agency, ESA, has been dependent on sites in other parts of the world. So, being the first of its kind in mainland Europe, the opening of Spaceport Esrange is an important step towards making Sweden a more significant space nation. The first satellite launch is scheduled for 2024. Another important space achievement took place on August 23rd, as India became the first nation to successfully land on the moon's south pole. On board, the lander carried a remote-controlled rover with a mission to make a first attempt to confirm the possible findings of frozen water made during earlier satellite flybys. Water that could make it possible for people to stay on the moon for longer periods and to produce fuels that could be used for future expeditions even further into space. During the mission, the Indian lander and rover will use a number of instruments, some of them made by parts built in Sweden.
And finally, one of the last year's greatest technological marvels, the James Webb Space Telescope, has continued to make revolutionary discoveries during the past year. One example is the discovery that a small exoplanet over 100 light years from Earth has an atmosphere containing a lot of carbon dioxide and methane, but also a small amount of dimethyl sulfide, which on Earth is only produced by living things. We don't know if this might represent life or conditions for it, but it is an indication that molecules of life are not unique to Earth. Ladies and gentlemen, the scientific discoveries and technological innovations achieved in 2023 have many things in common. They are grounded in excellent long-term research efforts. They're often challenged by the established research communities, and they are more often than not results of international collaboration and links between industry and academia. This recipe was behind the apparently fast and successful vaccine development that put a stop to the COVID pandemic, and that was acknowledged by the Nobel Prize in Chemistry or Medicine this year. And the same recipe is almost also about to prove itself concerning the research behind the Nobel Prize in Physics. The three laureates, among them our own IVA fellow, Professor Ann Ie, has given humanity new tools for exploring the world of electrons inside atoms and molecules. Tools that are now paving the way for new technologies, for example, in electronics and medical diagnosis. These achievements also indicate the importance of long-term investments in strong strategic research environments, such as Nanolund, where Ann has been working for many years. Thanks to long-term co-funding from the Swedish government since 2009, Nanolund has been able to grow into a cutting-edge research environment, attracting brilliant minds from all over the world. You have just heard some of the most exciting discoveries and innovations by Swedish scientists and engineers. However, countries that we are competing with are also getting stronger, thanks to their large investments in science and technology. A global race for technology leadership has toughened, and Sweden must be able to compete successfully in this race. Continued support and investments in excellent research endeavors and implementation of the results in society and industries are keys to our future competitiveness, sustainable development, and our continued welfare. Thank you.